In this video, I'm going to go through finding surface area of triangular prisms. The top portion of our notes look identical to yesterday's, except for this says triangular instead of rectangular. So I've just gone ahead and filled in those blanks already. Just as a reminder, total surface area does include the area of the bases. That's where we get this plus 2b from, because we have two bases. And it's kind of like wrapping a present. You want to cover every surface, that way whoever gets the present doesn't know what they're getting. And lateral surface area is kind of like a can, or putting, the label on a can. It only covers the sides. It does not cover the top or the bottom. I wrote down the formulas already, and I just want to talk about real quick what each variable represents. Capital P stands for the perimeter of the base. Perimeter, so how long along the edges of the base. And this lowercase h just stands for the height of the prism, so how tall is the shape going from one base to the other base, or how long was that base stretched to make it into a 3D figure. And capital B represents the area of the base. How much space does the base take up in 2 dimensions? So we're doing exactly what we did yesterday, except today we are using triangular prisms, which means our bases are triangles. So adding sides for perimeter, we'll only have 3 numbers, and our formula for big B will change from BH to 1/2 BH. The actual process itself does not change, because prisms are pretty similar. So we still have to redraw and label our base so that we can find capital P, capital B, and H. I've redrawn my base. I'm going to label everything that I know about it. This bottom edge here is 10 inches. And each slanted side is 12 inches. And it looks like our triangle is 11 inches tall. Now I'm going to cover up the triangular prism, because to find capital P and capital B, we only need the base that we've redrawn. Capital P is the perimeter, so just adding those sides together, 12 plus 12 plus 10, that is 34 inches. Now looking at capital B, that's the area of the base, which is a triangle. That's using the formula 1/2 BH. So 1/2 B and H in a triangle must make a 90-degree angle. That's this portion right here. So 10 and 11. So 1/2 times 10 times 11. 1/2 of 10 is 5. 5 times 11 is 55. So the area of this triangle is 55 inches squared. Now the height of the prism comes from the actual prism itself, not the base anymore. So I'm covering up the base and only looking at the prism. The height of the prism is how far was my triangle stretched to form a 3D triangle, essentially. How far is it from one triangular base to the other triangular base? We stretched this 6 inches. Now I have values for P, B, and H. So from here, this is just using a formula and plugging and chugging numbers, essentially. So our lateral surface area, we'll use the formula PH. Lateral surface area is PH. I'm putting a bubble everywhere I see a letter. This bubble is in place of a set of parentheses everywhere I see a variable. This parentheses is in place of capital P, the perimeter of the base, which is 34 inches. And this set of parentheses is in place of the height of the prism. The height of the prism is 6 inches. Now I've got 34 times 6, that's 180, and 24, so 204 inches. This is a type of area, so our units, inches, are squared. Now we're finding the total surface area. So this is kind of like two separate problems using the same picture, the same shape, the same information. To find total surface area, though, we have a longer formula, pH still. This gets me the area of all the sides, plus the area of both my triangular bases. So pH, bubble, bubble, plus 2 bubbles. Parentheses everywhere we see a variable. This set of parentheses is in place of the perimeter of the base, which is 34. This set of parentheses is in place of h, which is 6. And the final set of parentheses is in place of big B, capital B. The area of the base is 55 inches squared. I have to do the multiplication before the adding, because order of operations. 34 times 6 is 204, and 2 times 55 is 110. 204 plus 110 is 314, and this is the type of area, so the inches are squared. And that's all there is to it. Find P, V, and H, then you're using formulas. And this will work for any prism ever. You can use this for prisms with trapezoid bases and prisms with parallelogram bases. You can even actually use this for cylinders, these formulas for cylinders. But cylinders don't have perimeters, so when we do find surface area of prisms, we will find out what to do there. Moving on, now we have another triangular prism. We want to first redraw the base. And it's not labeled because I didn't label it when I was typing this up. That is a right angle there. This is 6 feet, 8 feet, and the slant inside the hypotenuse then, because this is a right triangle, is 10 feet. We need to find capital P, capital B, and H because we want to find surface area. And surface area uses the perimeter of the base, the height of the prism, and the area of the base. To find capital P and capital B, we need to look at the base, the 2D shape that we redrew, not the prism, the 3D shape that we've got. So I'm covering up the 3D triangular prism, and I want to find the perimeter and the area of this triangle. To find the perimeter of a triangle, you just add all of the sides. 6 plus 8 plus 10. 6 plus 8 plus 10. And 6 plus 8 plus 10 is 18, 24. 24 feet. Now the area of the base, capital B stands for area of the base, and the base is a triangle. How do we find the area of a triangle? We're using the formula 1/2 BH. That's 1/2. Base and height must make a 90-degree angle. So the numbers that form the 90-degree angles, or the lengths that form the 90-degree angle, are 6 and 8. So 1/2 times 6 times 8. Half of 6 is 3. 3 times 8 is 24. This is an area, so feet are squared. And to find the height of the prism, we clearly have to look at the prism and no longer the base. The height of a prism is how far is it from one base to its matching base, or how far did you stretch that base to make this a 3D figure. That was 12 feet. Now that we have the perimeter of the base, the area of the base, and the height of the prism, we're all set up to find lateral surface area and total surface area. Another thing we could find is actually the volume of this prism as well. Today we're focusing on surface area though, so no worries, only 2 problems instead of 3 here. Lateral surface area is capital P times H, the perimeter of the base times the height of the prism. I'm going to put a set of parentheses everywhere I see a variable. This bubble is in place of P, and P is 24. The perimeter of the base is 24. This bubble is in place of H, and the height of the prism is 12. Now I've got 24 times 12. My brain is not working tonight, so I am going to check my calculator. 24 times 12 is 288. And we're measuring this in feet, and because this is an area, this is feet squared. Now I'm looking for the total surface area, which uses a formula, perimeter of the base times the height of the prism, plus 2 times the area of the base. And my computer has frozen. Gonna fix that. There we go. Perimeter of the base times the height of the prism, plus the area of the base times 2, and that's because we have 2 bases. So putting a bubble or a set of parentheses everywhere I see a variable will allow me to make sure I have all my numbers in the correct spots. This bubble is in place of P. The perimeter of the base is 24. This bubble is in place of H, and the height of the prism is 12. This bubble is in place of B, and the area of the base is 24. So we have to do the multiplication before we can do the addition, order of operations. 24 times 12 is 288, and 2 times 24 is 48. 288 plus 48, 288 plus 48 is 336. We're measuring this in feet, and because this is an area, the feet are squared. Again, once you have found the perimeter of the base, the area of the base, and the height of the prism, this is a pretty simple algorithm or process that we can use to chug out a surface area. Now we've got a prism, but it's been unfolded from a 3D object, a 3D prism, to a 2D figure, so this is really a net of a prism. And remember we said that those flaps off to the side were going to be the bases. So I'm redrawing that triangular base. And it looks like our slanted sides, you know that they are the same length because of this indication here. Each has one line, which means those are the same. So those are both 7. The bottom of this triangle is 4. And there's a dashed line, so from the bottom to the apex of the triangle is 5 units. This means we're all set up to find capital P, capital B, and also H. Capital P and capital B come from the base, not necessarily the 3D shape, so I'm covering up the prism, and I can look at just the base. The perimeter of the base is just all the sides added together. The sides are 7, 4, and 7. Not that 5. The perimeter measures the distance around a shape, and the 5 is on the inside, so that's not going around the triangle there. We've got 7, 4, and 7. That is 18 units long. The area of the base, to find the area of the base, area of our base here is a triangle. So I need to know the formula for the area of a triangle. That is 1/2 base times height, or 1/2, remember base and height make a 90-degree angle. 1/2 times 4 times 5. Half of 4 is 2. 2 times 5 is 10. 10 units squared. Now we're looking at the height of the prism. Height is whatever connects the 2 bases together. Here's a base, and here's its matching base. The thing that connects those two shapes together is this line, which is measured at 9 units. So the height is 9 units. Now we're all set up to find lateral and total surface area. The formula for lateral surface area is just the perimeter of the base times the height, or pH, capital PH. I'm going to put a set of parentheses or a bubble everywhere I see a letter. This bubble is in place of P, and the perimeter of the base is 18. This bubble is in place of H, and the height of the prism is 9. And 18 times 9 is 90 plus 54, 72. 18 times 9, brain's just not working today, 162. And that is in units, because this is a type of area, surface area, that is units squared. Looking at total surface area, again, we get to use just a formula, pH plus 2b, pH plus 2b. Okay, so I'm gonna put a set of parentheses everywhere I see a variable. This bubble is in place of P, the perimeter of the base is 18. This bubble is in place of H, and the height of the prism is 9. This bubble is in place of capital B, and the area of the base is 10. So now we've got to do this multiplication, 18 times 9 and 2 times 10, before we can add their products. 18 times 9 is 162, and 2 times 10 is 20. 162 plus 20 is 182. We don't know the units. I'm using the word units, and because this is a type of area, this is units squared. This is an interesting little problem here. We've got somebody who has attempted to find it looks like lateral surface area of this prism. I know it's lateral surface area because of the formula. So they're using the formula capital PH, and they want to know what the error is. It looks like they have put 8 plus 15 plus 17 in place of P, and in place of H, they have put 8. I'm going to redraw the base just to get a better picture here. This is 8 plus 15 plus the hypotenuse. I know it's a hypotenuse because this is a right triangle, 17. So their perimeter would be accurate, 8 plus 15 plus 17. Their perimeter is accurate, so that's fine. So far we're good. Now the height is whatever connects one base triangle to the other base triangle. So this time we're looking at the prism, not the shape we've redrawn. How is this triangle stretched to become three-dimensional? How did we stretch this triangle, or how long is it from one triangle base to the other triangle base? That would be 18. And that's obviously the area there because they have used an 8. They said that this was the height, but that's not the height of the prism. That's the height of the triangle. So the error here is that they used the wrong value. They used 8 for H, but the height is 18. So if they had used an 18 there, they would have been set up correctly and hopefully done the adding and multiplying all nicely. So that is something that you do want to be very aware of as you're working this out, and that's why I really recommend that you redraw the base, cover up the prism, and then cover up the base and look at your two bases here to see how they're connected, what length they're connected by. That way you keep all of your numbers straight and you don't make this error. The next question says, or reads, the total surface area of a tent is 400 square feet. Fabric costs 52 cents per square foot. How much will making the tent cost? So they're selling 1 square foot of fabric for 52 cents. But we've got 400 of those, and we want to know how much would that cost. So if every single one is 52 cents, every is a keyword. Sorry, you can't see that. Every is a keyword for multiplication. So we've got our 400 square feet of tent. Multiply this by 52 cents per square foot, and that will give you how much total you would be paying. So we've got 400 times 0.52, definitely using a calculator here, and that is 208. That's about right. This should be a little more than half of 400, which is what we've got. So making this tent would cost you quite a bit of money to cover the tent in fabric. Cover or make the tent this fabric. Being realistic, if I were to give you a homework problem or a test question, I wouldn't flat out tell you the surface area is this. I'd ask you to find it. Maybe I'd give you a picture and ask you to find the cost. So you'd have to find out that that the surface area was 400 and then multiply it by the cost. I just wanted to kind of show you a little bit behind the scenes why we are multiplying that. So this is all the content I have for this video on surface area of triangular prisms. Just to recap, that's page 159 in your binders. If you have questions about the content in this video or the content in general, please reach out to me via Schoology, email, or drop a comment, and I'll get back to you as soon as I can.